Hello and welcome to the OpShin Pioneer Program Week 3, Lecture 3. And here we look at a specific contract which is called a vesting contract. And based on a real-world example, because in a lot of situations you want to lock away, you want to gift or ensure that someone will obtain funds in the future, but cannot access them until a certain time. So this is, for example, used when you have a child that's not of legal age yet, but you want to make sure that it inherits something from you. Then you can lock funds. And the contract specifies that the funds can only be accessed the earliest in 20 years, for example. So let's have a look at how we could implement such a contract, such an intent, using a smart contract in Cardano. First, what we have defined here is a custom data type. So let's set the constructor ID here as well. Just any constructor ID, and then we have a beneficiary, which is the person in our example. It's the person that should be able to withdraw the funds after some time. And we have a deadline, which is the time after which the funds get unlocked. So the intent is that after deadline has passed, a person can withdraw their funds, the beneficiary can withdraw their funds from the smart contract. So then we have some definitions, and now we have validator. So here we see more specifically what I mean when I say the datum is a state of a smart contract. So now we use the first parameter to the validator, and the type is vesting params. That's what we just defined. And this basically defines for a specific output, okay, this person can withdraw it after this time. So we can have the same contract address, we can have many outputs there, and all of them have a datum attached. And this datum just specifies for each of them who can withdraw it when. And so we have a nice overview. We know that we can trust the contract and that it's just parameterized by these values. By this custom data type. And now in this case, actually the redeemer is none. We don't really care about the redeemer because there's only one action to be spent, only one way to spend funds from this, which is to withdraw the funds as soon as we are allowed to. And we now use the context because we need some external information. We need to make sure that in this transaction there's a signature from the person that should withdraw the funds, and that the current time after which in which the transaction is valid is actually matches what we expect from the deadline. So the first, we have basically two checks in this validator. It's a very simple script. The first check checks that only the funds can only be spent if the person that has this secret key matching to the beneficiary public key has signed the transaction. So in other words, we make sure that only the person that knows the secret key can actually spend the funds. And this we check by accessing the field beneficiary from the parameters, and then checking that it's in the list of signatories and the list of people that have to have signed the transaction according to the Cardano node. And this returns a Boolean value. So this just checks this value is in this list, returns a Boolean test whether it's contained or not, and then we assert that this is true. And if it's not true, we log an error that some signature is missing. Secondly, we want to make sure that the deadline that we specified is reached, right? It's not enough to have the person that we want to give the funds to have signed the transaction, but it should not be, even that person should not be able to withdraw the funds until after several years that we specified. So what does deadline reach do? It takes the deadline from the vesting parameters, and it takes the validity range of our transaction from the context, and then it calls the function isAfter, which we have defined. It's just a custom function that we defined for convenience. And what this does is it takes it constructs using this make from, constructs the time from the deadline up until all of infinity, of all of positive infinity, and then we check that the time from deadline to infinity contains the validity interval. So we don't want the validity interval to start before the deadline, so because that would mean that the transaction could actually be spent before the deadline, and it cannot be later because that's not possible, as the upper bound is infinity. But anyways, we just want to make sure that it's there. And yeah, and we call contains, which is defined in the ledger in the standard library basically of OpShin, and there it's just really comparing some lower and upper bounds. If you want to dive a bit deeper into this, you could think about how we can make this more simple, because this is now using very complex mathematical way to think about it, which is with these intervals and containment. But because we know the structure of this from interval, you might think for yourself about the way that we can make this check more efficient. But this I'll leave you as an exercise. And okay, thank you for listening in, and let's look at deploying this in the next lecture.